Hello everyone, welcome back to my channel. I am Vamshik Shetty, pursuing third year B in Sri Venkateswara College of Engineering, Bangalore. Today in this video, we are going to discuss about the major topic in the computer network, that is transmission media in the physical layer. So let us discuss about the each and every topic in the transmission media. First, let us discuss about the what is transmission media. Transmission media is an essential component of the physical layer of a computer network. A transmission media can be broadly defined as anything that can carry information from a source to a destination. It refers to the physical pathways that connect computer servers and other devices. You can see the transmission media in the given figure, that is the transmission that takes place in the sender to the receiver with the transmission media, for example cable or hair. So this is about the transmission media. Now let us discuss about the categories of transmission media. Transmission media in the physical layer is broadly classified into two types. These pathways can be either guided or unguided, with its unique characteristics and application. Each type of media has its unique characteristics and application, making them suitable for different types of communication needs. Whereas the guided transmission media is also called as wire transmission media, and the unguided transmission media is also called as wireless transmission media. Now let us discuss about the each and every topic in the guided and unguided transmission media. First, let us discuss about the guided media, where guided media, which are those that provides a medium for one device to another, include magnetic media, twisted pair cable, coaxial cable, and the fiber optic cable. Some of the categories under the guided media are magnetic media, twisted pair cable, coaxial cable, power lines, fiber optic cable. So these are the five categories that comes under the guided media. Now let us discuss about the each and every category that comes under guided media. First, we're gonna discuss about the magnetic media. One of the most common ways to transport data from one computer to another is to write them onto magnetic tape or removable media, that is example recordable DVDs. Physically transport the tape or disc to the destination machine and read them back in again. Although this method is not as sophisticated as using geosynchronous communication satellite, it is often more cost effective, especially for application in which high bandwidth or cost per byte transported is the key factor. No computer can even approach this. So this is about the magnetic media. Now let us discuss about the another type of the guided media, that is twisted pair cable. One of the oldest and still most common transmission media is the twisted pair. A twisted pair consists of the two insulated copper wires, typically about 1 mm thick. The wires are twisted together in the helical form, just like a DNA molecule. Twisting is done because of two parallel wires. One of the wire is used to carry the signals to the receiver, and other is used only as a ground reference. A typical diagram of the twisted pair cable is given here. You can see that, which is covered by the two pair of copper wires, which is twisted together in an helical form. So this is about the twisted pair. Now let us discuss about the third category, that is coaxial cable. A coaxial cable consists of a stiff copper wire as the core, surrounded by an insulating material. The insulator is encased by a cylindrical conductor, often as closely woven braided mesh. The outer conductor, which is covered in a protective plastic shell. Two kinds of coaxial cable are widely used. One kind is of 50 ohm cable, which is commonly used when it is intended for the digital transmission from the start. The other kind has the 75 ohm cable, which is commonly used for the analog transmission and the cable television. So there are the two types of the coaxial cable, that is 50 ohm and the 75 ohm. So this is about the coaxial cable media. Now let us discuss about the fourth category, that is power lines. The telephone and the cable television networks are not the only source of wiring that can be reused for the data communication. There is a yet one more kind of wiring, electrical power lines. The power lines deliver electrical power to houses, and electrical wiring within houses distribute the power to electrical outlets. The use of power lines for the data communication is an old idea. Power lines have been used by electricity companies for low rate communication, such as remote metering for many years, as well as in the home to control the devices. So this is about the power lines, and the working of the power lines is shown in the figure. So now let us discuss about the last category in the guided transmission media, that is fiber optic cable. A fiber optic cable is made of glass or plastics and transmits the signals in the form of light. The light travels in a straight line as long as it's moving through a single uniform substance. If a ray of light traveling through one substance suddenly enters another substance of a different density, the ray changes the direction. Optical fibers uses the reflection to guide light through a channel. A glass or plastic core is surrounded by a cladding of lens of less dense glass or plastic. So we can see that in the figure we can see that the optic, how does the working of the optical figure works is it is composed of cladding core, where core is surrounded by cladding on the both sides. The the light transmission takes place in the core part, where it is transformed as shown in the figure. So this is about the transmission of the signals from sender to receiver in in the case of fiber optic cable. So these are the some of the guided transmission media. Now let us discuss about the unguided transmission media. Unguided transmission media, which is also called as wireless transmission media. Unguided media refers to the wireless pathways that transmit signals through the air or space, such as radio waves, microwaves, or infrared signals. Some of the categories that comes under in the unguided media, that are electromagnetic spectrum, radio transmission, microwave transmission, infrared transmission, and the light transmission. So these are the five categories that comes under in the unguided media. Now let us discuss about the each and every category in the unguided media. First we are gonna discuss about the electromagnetic spectrum. The wireless signals are spread over in the air and are received and interpreted by the appropriate antennas. When an antenna is attached to an electrical circuit, the electromagnetic waves can be broadcast efficiently and received by a receiver some distance away. All wireless communication is based on this principle. In a vacuum, all electromagnetic waves travel at the same speed, no matter what their frequency. This speed is called the speed of light, that is c, which is approximately 3 into 10 power 8 meter per second. In copper or fiber, the speed slows to about 2 by 3 of this value and becomes slightly frequency dependent. So some of the electromagnetic spectrum is given here, where radio waves varies from 10 to the power 1 to 10 to the power minus 1, where electromagnetic waves vary from 10 power minus 1 to 10 power minus 3, where infrared varies from 10 power minus 3 to 10 power minus 5. So we are majorly discussing about the radio waves, microwaves, and the infrared waves in this unguided media. So this is about the electromagnetic spectrum. Now let us discuss about the radio wave radio transmission. The radio frequency is easier to generate, and because of its large wavelength it can penetrate through walls and structures alike. Radio waves can have wavelength from 1 mm to the 1000 sorry 1 lakh kilometer, and have frequency ranging from 3 hertz extremely low frequency to 300 gigahertz extremely high frequency. So the lowest frequency is 3 hertz and the highest frequency is the 300 gigahertz. The radio frequencies are subdivided into six bands. The radio waves at lower frequencies can travel through the walls, whereas a higher radio frequency can travel in a straight line and bounce back. The power of the low frequency waves decreases sharply as they cover long distance. So the typical example of the radio transmission is given in the figure, where it can travel up to the 1 mm to the 1 lakh kilometer with the frequency ranging from 3 hertz to 300 gigahertz. So this is about the radio transmission. Now let us discuss about the microwave transmission. In the electromagnetic waves, about it, the transmission has the waves above 100 microhertz tend to travel in a straight line, and signals over then can be sent by becoming those waves towards one particular station. Because microwaves travels in a straight line, so both sender and receiver must be aligned to be strictly in line of sight. Microhertz can be have wavelength ranging from 1 mm to 1 meter, and frequency ranging from 300 microhertz to 300 gigahertz. Microwave antennas concentrate the waves, making a beam of it as shown in the picture above. Multiple antennas can be aligned to reach farther. In the microwave transmission, it has the ranging from 1 mm to 1 meter, and the frequencies will be ranging from 300 microhertz to the 300 gigahertz. So this is about the microwave transmission. Now let us discuss about the infrared transmission. So this is the fourth of transmission in the unguided media, where infrared transmission, the infrared wave in the infrared transmission, the infrared wave lies in the between the visible light spectrum and the microwaves. It has wavelength around 700 nanometer to the 1 mm, and the frequency ranges from the 300 gigahertz to the 430 terahertz. Infrared wave is used for a very short range of communication purposes such as television and its remote. Infrared travels in a straight line, hence it is a directional by nature. Because of high frequency range, infrared cannot be cannot cross the wall-like obstacles. In the some of the major point we are going to discuss here. The infrared has the wavelength around 700 nanometer to 1 mm, and the frequencies will be ranges from the 300 gigahertz to 430 terahertz. So in the major disadvantage of the infrared transmission is the because of its high frequency range, infrared cannot cross the wall-like obstacles. So this is about the infrared transmission. Now let us discuss about the last transmission in the unguided media, that is the light transmission. The highest, most electromagnetic spectrum which can be used for the data transmission is the light or optical signaling. This is achieved by means of laser. Because of frequency light uses, it tends to travel strictly in a straight line. Hence, the sender and the receiver must be in a straight line of sight. Because laser transmission is unidirectional at both ends of the communication, the laser and the photo detector needs to be installed. Laser beam is generally 1 mm wide, hence it is a work of precision to align two for receptors, each pointing to the laser source. So this is about the light transmission, where the typical examples of the light transmission is given in the below figure. So this is about the all the unguided transmission, where we are going to discuss about the transformation media in this video. The transmission media has the guided transmission and the unguided transmission. In the guided transmission, we have discussed about the magnetic media, coaxial cable, twisted pairs, power lines, and some other categories. Where in the unguided media, we have discussed about the electromagnetic spectrum, radio transmission, microwave transmission, infrared transmission, and the light transmission. This is about the transmission media. So that's it for this video. For more videos, please like, share, and subscribe the channel. Thank you.